Today's lesson is about how to solve systems of equations using the elimination method. Your learning target says, I can solve a system of equations using elimination. Using the elimination method, we are going to eliminate one of the variables. And in order to do that, we are going to utilize addition. So I'm going to show you what happens if I were to add these two equations together. My y's would cancel out, also known as being eliminated. So I am eliminating one of my variables. I would have 5x's on one side and 25 on the other. Now it'll be easy for me to solve for x. I can simply divide both sides by 5. And I believe my answer is x is 5. And that is half of my answer. My answer that I'm looking for in this case is going to be an ordered pair. And so by eliminating my y's, I was able to solve for the x. But I now have to decide how much my y is. And I can pick either of these original equations. I usually pick the first one. And if I know that x is 5, I can simply plug the 5 in for the x, rewrite the equation. 2 times 5 is 10. 10 plus my mystery number is 9. When we solve this, we're going to subtract 10 from both sides. And it looks like y is going to be -1. So once you know what x is, you can replace it into either one of the equations and find out what y is. Now this is in yellow, so I'm not sure how much you can read it. But the solution ordered pair, if x is 5, it goes in the first spot. And if y is -1, that goes in the second spot. And so the ordered pair that is the solution to this system would be 5, -1. It would be really nice if that elimination method always worked right off the bat, that things just lined up perfectly and I was able to eliminate one of my variables. But if we do our process here and I add them together, let's see what happens. So an x plus another x, that would give me 2 x's. A -2y and a +3y would give me a y. -9 plus 16 would give me 7. None of my variables was eliminated. So this one appears to not work. Well, yet. So let's think back. Our original equation was x minus 2y equals -9. Our original system, sorry. And x plus 3y equals 16. If I'm looking to eliminate either my x's or my y's, it might be best to eliminate my x's. And that would be possible if only one of them was a negative. Well, let's think back to when you first learned about equations, and it was probably years ago, not just this year. And you learned that if you do something to the left side of the equation, if you do the exact same thing to the right side of the equation, you really haven't altered your equation. That's an interesting concept that might help us here. So for example, if I were to take this left side, say, times -1, and the right side times, say, -1, let's see what would happen. All right, I did not alter this top equation of my system. But on the bottom one, if I take -1 times x, I'm going to get a -x. -1 times 3y, a -3y, and 16 times -1 is -16. Well, that looks much better. If I were to add these together, then I would be able to eliminate my x's, and I would have -5y's on one side and -25 on the other. And now things are looking better. So if I divide both sides by -5, I think y is going to be a positive 5. Well, that's half of what I need. Remember, the other step is to take either original equation. I'm going to pick the first one always. I don't know what x is, but if y is going to be 5, I'm just going to plug that in where the y used to sit and recopy the rest of the equation. So now I have x minus 10 equals negative 9. I'm going to solve by adding 10 to both sides. And x will be 1. And my ordered pair will be 1, 5. All right, so here's one. I wonder what we should do in this case. Obviously, if we add these together, nothing good is going to happen. Nothing is going to be eliminated. But I think maybe if we were to multiply this top one by 4, both sides, something might happen that is going to make this easier for us. So there's your hint. I want you to pause me and work this out, and when you're ready, come back for checking. If I multiply both sides by 4, I will have 8 x's minus 4 y's on one side and 36 on the other. I didn't alter the bottom one, so that will remain. And now, if I were to add them together, I would have 11 x's, but my y's would be eliminated. And on the other side, I'd have 22. And now I can solve that by dividing both sides by 11. I believe x will be 2. Once I know half of my ordered pair, I can figure out the other half. I'm going to go back to this original, not the new and improved, but the original one, where I had 2 times x, and we think x is 2, so I'm going to plug that in, minus y equals 9. Well, that would be 4 minus our number is 9. So I can solve for y. I can subtract 4 from both sides. But remember, that's going to give me a negative y on one side and 5 on the other. So I'd have to divide by my negative 1 to get y by itself. I think y is going to be negative 5. And once you know your x and you know your y, you have your ordered pair, which is your solution. All right, you're on your own for this one. I want you to solve the entire thing, pause while you're working, and come back when you're ready to check. Okay, now I'm going to choose, because neither of these variables will be eliminated, I'm going to choose to multiply both sides by negative 3. That does not make it the only option. It doesn't make it the best option. It simply makes it the option I chose. So you might not do it this way, and that's fine. That leaves the top equation of my system good like that. And the bottom, I would get a negative 12x and a positive 3y and a negative 6. I think something interesting is happening here. Those eliminate, and that eliminates. So I have nothing on the left and I have nothing on the right. When that happens, when you have, in this case, 0, but it could be any number on both sides of your equation, that simply means that you are going to have an infinite number of solutions. If you remember, you might have one solution to your system, and that's going to be an ordered pair. And we've had that quite a bit. But in this case, we are going to have an infinite number of solutions. And the reason we have an infinite number of solutions is because these are the same line. If you were to graph this, one would be directly on top of the other. So you have an infinite number of solutions. So my answer is infinity. Or you might have no solution. In that case, you would have parallel lines where you are never going to have an intersection. So because this is always going to be true, I have one line on top of the other. For every x value and every y value, I have an infinite number of solutions. All right, let's try a story problem. Now in story problems, I'm going to look down here. How many of each bill does she have? I don't necessarily want an ordered pair as my solution. So I'm not going to choose to use x's and y's because for me, other letters might be more helpful to me. So let me show you what I mean. It says a family member has some $5 bills and some $1 bills. Altogether, she has 18 bills for a total of $62. So for me, I'm going to say F for $5 bills plus D for dollar bills. There were 18 total bills. Some of them were fivers, some of them were singles, 18 bills. But then when we're talking value, 5 times the number of $5 bills plus 1 times the number of $1 bills had to equal the $62. If I were to add these, nothing would get eliminated. So from here, will you pause me and solve this? Come back when you're ready for checking. All right, well, what I'm going to choose to do is I'm going to choose to multiply this by -1 and this by -1. And what's going to happen when I do that? I get a -1f and a -1d and a -18. This guy was unchanged, so I'm just going to copy that. And now if I add, my dollar bills will be eliminated. So I'll have 4 $5 bills that are going to equal $44, which means that I must have, or this person must have, 11 $5 bills. Once you know that, you can go to your original. The number of $5 bills plus the number of singles equaled the 18 total bills in the wallet. I could solve that and find out that this person had had $7 bills. So the answer to my problem is that she had 11 $5 bills and 7 $1 bills. I want you to try this one all by yourself. Can you find the two equations that make up the system? And once you have those, can you solve it and tell me the angle measurements of the two angles? So pause me while you're working and come back when you're ready for checking. Okay, so it says that one angle measures 54 more than 3 times the other. So one angle equals 54 more than 3 times the other. And I'm just arbitrarily putting an X and Y. They don't really mean anything. They don't stand for anything other than those are the two angles. And then it says that they are supplementary. So X plus Y equals 180 degrees. All right, well, I already have a problem because I have my X and my Y on both sides here, but I have my X and my Y on opposite sides there. So let's at least get these looking right or similar to each other. So if I want my X and my Y to be on the same side, I could certainly subtract. I'm going to change this one, I think. I could certainly subtract 3 X's from both sides on that one. And then I could just simply line up this one. And that'd be awesome, except for the fact that nothing's going to cancel. So I did my algebra fine, but I still have a problem because I think I need to multiply this. Let me change my color, make it blue. Multiply this by -1, and multiply that by -1. I think that will then give me 3 X's and a -Y is over -54. And then if I line things up, I'll be able to eliminate my Y's. All right, so when I add these together, I have 4 X's on one side and 126 on the other. Divide by 4, and X looks like it's going to be 31 5/10 degrees. So I can simply plug that in any equation I want. I'm going to take this original one right here. Y is 54 plus 3 times my X. And so if I do that, I didn't figure out what 3 times. So 3 times 31 5/10 plus 54. That means Y is going to end up to be 148.50. So my sentence would be, my angles are 31.5 degrees and 148.5 degrees. Those are the angle measurements. Last one. I want you to try this one without me again. See if you can find the 2 equations that are going to make up your system. Can you use elimination then to figure out how much would 2 large buckets of popcorn and 3 boxes of candy cost? So pause me while you do this and then come back for checking. So it looks like we have 4 buckets of popcorn plus 6 candies are going to equal $46.50 on one movie trip. And the last time we had 1 large popcorn and 1 candy, and that cost $9.75. If I add those together, nothing is going to cancel. So I have to do something. And so I feel like I really want to take this second equation and I want to multiply it by -4, both sides. All right, I'm going to work at the bottom. So I had my first equation that I did not change. And my second one, I multiplied everything by -4. And if you look, it's because then my popcorns are going to cancel. And this would be -39. All right, so when I add them together, popcorns are eliminated. I have 2 candies. That would be $7.50. That means 1 candy will be $3.75. That's awesome. I'm going to go up to this original equation right here. A popcorn plus a $3.75 candy equaled $9.75. So it looks like my popcorn then would be $6. But that's not the question. The question is, how much would 2 buckets of popcorn and 3 boxes of candy cost? So I'm going to write in red. I have to find a little spot where I can work on this. So 2 popcorns at $6 each and 3 candies at $3.75 each. The actual answer to this problem is $23.25. Oops, I can't make that fit. Let me find a different place to put my equals sign. Equals $23.25. So that was kind of a long and involved problem. All right, we are all done. We'll be practicing solving systems with elimination in class.